So this is the notes for lesson 4. We're going to be transforming exponential logarithmic equations. The nice thing about this topic is you've done a bunch of different transformations in the past, and those transformations, all those topics and ideas, they all transfer to these two. So all the transformations you've done in the past work for all these other equations. It's just the equations look a little bit different because they're different types of equations. Okay, so let's get into it. We're going to be using an exponential equation first, so you have the different things that we've seen in the past. They work the same here, again, as they have in the past. So A, that's when you're multiplying something at the outside of the function. That is going to be your vertical stretch or compression. B, when you're multiplying something to the inside of the function, and that is going to be your horizontal stretch or compression. Your C value here is going to be a horizontal shift, either left or right. And the D value on the outside is going to be if you move something vertically, either up or down. Okay, so let's get into it. I'm going to show you how these work. We're going to be basing all our stuff off of our equation here of f of x equals 5x, 5 to the x, sorry. All right, and what we're going to do is we're going to show you examples of these with numbers in them to make it understandable, okay, hopefully. So the first one, you have a vertical stretch. So we're going to take our g of x function. All right, we're going to multiply the f of x, or sorry, 5 to the x. We're going to multiply 5 to the x by a number. So we're going to pick 2. So it's 2 times 5 to the x. And this is going to be our vertical stretch. So this is going to make the graph stretch vertically by a factor of 2. Okay, for compression, we're going to take our function. We're going to multiply it on the outside by a fraction. All right, and that 1/2 on the outside is going to be our vertical compression by a factor of 2. All right, if we want to reflect something over the x-axis, we're going to multiply our function on the outside of the function by a negative sign, technically -1. Okay, and that negative is going to be reflecting it over the x-axis. Okay, now we move to horizontal. So horizontal, you are multiplying the inside of the function by a number. So in this case, we're going to get g of x is equal to 5. So a stretch is going to be the opposite of the stretch for vertical. So for horizontal, we're going to do multiply by a fraction. So we have 5 to the 1/2 times x. All right, and then same thing for horizontal compression. We're going to have our function g of x is equal to 5, and we're instead of a fraction this time we're going to do a whole number, 2 to the x, or sorry, 5 to the 2x power. There we go. All right, and then for reflection over the y-axis, we're going to multiply our x value by a negative number. In this case, we're just going to pick -1. All right, and that negative on the x will reflect the graph across the y-axis. All right, for horizontal shifts, left and right, we're going to add or subtract a value inside the function on the x. So because we're going left, we're going to add, all right, and it's inside the function on the x. If we're going to go to the right, we're going to add or subtract. In this case, because we're going right, we're going to subtract a number inside the function. That's a really ugly 2. Let's go back and fix that. There we go. All right. Now, what a horizontal shift, either left or right, will do to the graph in an exponential function, it won't really do much in terms of like, it would shift the graph, but it's not going to do anything in terms of the aspects of what the graph is doing. Like, are there any limitations on it? What a horizontal shift will do in an exponential function, though, is it will change the vertical asymptote of its inverse. Notice this is the inverse of that function that we've been using. Okay, so if our graph normally looks like this, okay, its inverse is going to look like upside down. And then this inverse has a vertical asymptote. Okay, and that horizontal shift will change the vertical asymptote on the inverse. All right, let's look at vertical shifts. So this is adding or subtracting the outside of the function. So we have 5 to the x power plus 2. Okay, notice it's not in parentheses inside the function. It's on the outside of that function. All right. And it is going along with the sign on the number. So if it's plus, it's going up. And if it's going down, that means it's going to be a minus. Okay. Now what a vertical shift will do in an exponential function is it will change the actual function, in this case of the graph, or the shape of the graph, because it will have the horizontal asymptote will be changed of this exponential function. Okay, if you remember, again, just above, an exponential function looks like this. It has a horizontal asymptote. Well, if you change the graph vertically going up or down, that horizontal asymptote will also change. Okay, let's do some examples of describing the different transformations for these equations. Okay, I'll give you two different types to kind of prepare you for what might be on the test. Okay, so we are doing 7 to the x as our graph, or sorry, as our equation. Okay, so each one of these has 7 to the x at the top, and then we're doing that function inside for the bottom 3, and it's just showing you as a function notation version what would happen with those transformations. Okay, so for the first one, we have an horizontal shift, and it's going to go horizontal. I'm gonna abbreviate here. Horizontally, it's going to go to the left by 4. Okay, and then last, there's only 2 of them in this case. That is going to be a vertical shift. It's going to go down 1. Actually, I should put down that this is a shift. Oops, forgot the T. All right. There are 3 different transformations on part B. Okay, the first one is the minus sign in front of the 3. This is a reflection over the x-axis. Make this a little bit bigger. All right. Then we have the 3 itself. This is a vertical stretch. Oops. By 3. All right, and then finally we have the interior, all right, inside the function horizontal shift. And it's going to the left by 1. Okay, so those are the 3 different transformations on part B. All right, part C. All right, we have the 1/4. This is a vertical compression. All right, by a factor of 4. All right. This negative sign is going to be a reflection over the y-axis. And lastly, we have a vertical shift up 4. Okay. All right, now let's look at the other 3. It's a different format, but it's asking the same things. Okay, so the first thing is we have this 2 on the inside, so this would be a horizontal, and this would be a compression. By 2. And we have a vertical shift. All right, going up by 3. All right, part E. There are 4 different transformations in part E. First one, we have that negative sign on the outside. This is a reflection over the x-axis. The 4 is a vertical compression, or sorry, vertical stretch. That's really ugly. By 4. There's a horizontal shift going to the left by 1 because it's on the inside. And then lastly, on the outside here, we have a vertical shift and we're going down by 5. Okay, last one on the exponential functions. We have a vertical compression by a factor of 3. All right, and then this negative sign on the inside is a reflection over the y-axis because it is on the inside on the x itself. Okay, so that's the transformations for an exponential function. The second page of the notes is going to be transformations on logarithmic functions. It's the same idea again, okay, of what's going to happen to a logarithmic function. Okay, so we have A as our vertical, either stretch or compression. The B value is going to be the horizontal stretch or compression. The C value is going to be a horizontal shift. And the D value is going to be a vertical shift. Okay, so it works the same way. So we have log of x, okay? So remember, there's no base written, so that means the base is 10, so we don't have to write it. So we have g of x. So a vertical stretch means we're going to multiply by something on the outside, so 5 times the log of x. Okay, and a vertical compression, we're going to use 5 this time for all our numbers. It's going to be 1/5 times the log of x. If we want a reflection over the x-axis, we're going to multiply the log of x by -1. Okay. Next we have our horizontal stretch. Again, it's the reverse of what the vertical stretch was, and it's on the inside. So we have log of, we're going to put it in parentheses, 1/5 x. So a compression is going to be g of x is equal to log of 5x. All right, and then lastly, a reflection over the y-axis is going to be where our g of x function is going to be multiplied by -1 on the inside on the x itself. And that will flip it over the x-axis, or sorry, the y-axis. Okay. For horizontal shifts, we're going to either add or subtract on the inside of the function. So if we're going to go left, we want to do +5. If we want to go right, we're going to go -5. All right. Now, in the previous problem with the exponential functions versus the logarithmic functions, all right, we saw here that the shifting horizontally would change your vertical asymptote of the inverse. But this is the inverse of an exponential. So this is where your vertical asymptote is going to change. This graph will look like this, and it has a vertical asymptote. So a horizontal shift is going to change whatever position that vertical asymptote is going to be in. Okay. When we get to the vertical shifts, again, you're going to be adding on the outside of the function. So g of x is equal to log of x plus 5. Now notice, for the horizontal shift, it was in parentheses. Now it's not in parentheses, which means it's on the outside. For the vertical shift down, and minus 5. Now, unlike last time, a logarithmic function does not have a horizontal asymptote, but its inverse does. So here's a logarithmic graph, okay, and it has a vertical asymptote, but its inverse, a logarithmic inverse, is going to be an exponential graph, which means it's going to be like this. And this one has a horizontal asymptote. Okay, so when you do a vertical shift on an logarithmic graph, it will change the horizontal asymptote of its inverse. All right, so again, let's look at some examples of these types of functions. Okay, so two different types. So the first one, there's two transformations. We have, or to make this bigger, we have a horizontal shift to the right by 1. And we have a vertical shift up 2. Okay. All right. Next, we have 3 different transformations. We have a reflection over the x-axis. That is the negative sign. All right. The 3 is a vertical stretch by 3. And the 4 is a vertical shift up by 4. Last one of this type, we have a horizontal compression by 2. And we have a vertical shift down by 7. Okay. Now, since we're dealing with these functions still, with the log functions, this time it's in a different format, but the same rules apply. So the first one, we have 2 different transformations. We have a vertical compression by a factor of 2. Oh, sorry, of 5. Apologies. And we have our horizontal shift going to the left by 2. All right, the second one here, we have a reflection over the y-axis because it's on the inside of the function being multiplied by the x. We have a vertical shift that's going up by 6. Okay, and the last one, we have 4 different transformations. First is the negative. It's a reflection over the x-axis, because this one's on the outside of the function. We have a vertical stretch. That's not pretty. By 3. We have a horizontal shift on the inside, and it's going to the left by 2. And lastly, we have a vertical shift. It's going up, oh, sorry, it's going down by 1. Okay, and that's it. That is the different examples of transformations for either exponential or logarithmic graphs, and we will see